Hi everyone, Assalamualaikum. In this section, we are going to take a look at an application of differentiation, which is linear approximation using differentials. Linear approximations can be used to estimate the amount of function value changes as a result of a small change in the input. Linear approximation is a method for estimating a value of a function near a given point using calculus, right? In this lesson, you will learn how to find a linear approximation and see an example of how it can be used. Alright, under linear approximation, we use this formula, right? So you need to memorize this formula. Fx equals to fx naught plus delta x approximate to fx naught plus f prime x naught times delta x, right? This is the symbol for approximation, right? Hot tips. Right, x here means equals to x naught plus delta x. Okay, x equals to x naught plus delta x. X here means the given decimal numbers. X naught means nearest whole numbers. And delta x means small changes, which is decimal value between -1 to +1. Right? Delta x can be negative value or positive value between -1 to 1. Right? Alright, let's say we have decimal number 9.02. Okay? From this formula, x equals to x naught plus delta x, we can write 9.02 equals to 9 plus 0.02, right? 9.02 means x, which is the given decimal numbers, right? 9 means x naught, which is nearest whole numbers. Okay, nearest whole numbers for 9.02 equals to 9, right? And 0.02 means delta x. Okay, we look at here. Okay, delta x means small changes, which is decimal value between -1 to +1, right? How about example 2? Let's say we have 8.97. Okay, we can write equals to 9 and then plus -0.03 because 9 plus -0.03 equals to 8.97, right? Now we look one by one. 8.97 means x, okay, which is the given decimal numbers. 9 means x naught, which is nearest whole numbers. Okay, the nearest whole numbers for 8.97 is equals to 9, right? -0.03 is delta x. Okay, we look here. Delta x means small changes, which is decimal value between -1 to 1. Okay, this is decimal value between -1 to 1, right? Alright, how about if we write 8.97, okay, the same value here, equals to 8 plus 0.97. Okay, 8 plus 0.97 is equals to 8.97. Alright, 8 here means x naught. Okay, we recall back. X naught means nearest whole numbers. Okay, but 8 is not a nearest whole numbers for 8.97 because we have 0.9 here, right? Means that this is wrong. Okay, so this is wrong choice, right? F prime x naught times delta x here is equals to dy. And dy here means differentials, right? Alright, now we look at example 1 from previous semester papers, April 2011, question 3b, 5 marks. Alright, use differentials to estimate the value of square root of 36.02 and give your answer correct to 4 decimal places. Right? Okay, first, we can list down the steps to solve differentials. Alright? First step, find x naught and delta x. And then second step, find fx and the value of fx naught. And step 3, find f prime x and the value of f prime x naught. And step 4, we use this formula to approximate. Alright? Alright, from the given formula here, right, we need to find x naught, okay, in step 1, okay, and then we need to find delta x from step 1, okay, and we need to find fx naught from step 2, and f prime x naught from step 3, okay, before we use approximate formula. Alright? Alright, what is x? Okay, we recall back. Okay, x is the given decimal numbers. What is x naught? X naught is nearest whole numbers. And what is delta x? Delta x is small change in decimal value, right? Between -1 to 1. Alright? So, from the given question, square root of 36.02, we can split to nearest whole number plus small change. Okay, the nearest whole number to 36.02 is 36. And then to get back 36.02, we must plus 0.02. Okay, and then the given decimal numbers, we denote as x. Okay, 36 here, the nearest whole number equals to x naught. And the small change between -1 to 1 here in decimal value, okay, equals to delta x. Alright? And x equals to x naught plus delta x. Okay, x here 36.02 equals to x naught 36 plus 0.02. Right? So from here, when we compare, our x is 36.02 here. Our x naught equals to 36 and delta x equals to positive 0.02. Right? And then step 2, we need to find fx and the value of fx naught. Alright? So fx equals to square root of x. Okay, how we get this? Okay, from here. Okay. Just now we assume the given decimal value equals to x. And the given decimal value inside square root. Okay, so we have square root of x. And when we compare, it is actually the given question. So means that the given question, okay, we can write square root of x, which is fx because it is in variable x. Alright? Alright, after that, we need to find the value of fx naught. So it means that we just replace our x here by x naught. Okay? So fx equals to square root of x. Means that fx naught equals to square root of 36 because our x naught in step 1, we have 36. And then when we solve square root of 36, it is equals to 6. Okay, which is whole numbers. So if we get 6 here, okay, if we get whole number for f(x naught), means that we choose the best value for x naught. Okay, means that 36 is the best value. Right? Because when we solve f(x naught), okay, when we substitute 36 into x naught, we get whole numbers. Right? Okay, and then step 3, find f prime x and the value of f prime x naught. Okay, from step 2, we have fx equals to square root of x. Okay, to find f prime x, we need to differentiate. And to differentiate square root, we need to change into the form of power. Right? So we can write square root of x equals to x the power of half. Alright? And after that, we can differentiate. So we have f prime x. And when we differentiate x the power of half, we can use power rule. Okay? And when we use power rule, means that we move power to the front and then x and then power minus 1 means half minus 1 equals to negative half here. Okay? And after that, we can write x the power of negative half into third x. How we get third x here in denominator? Because from properties of indices, we can move down x the power of negative half to numerator, and we have x the power of positive half. And x the power of positive half is third x. And 2 here comes from half here. So that's why we can write 1 over 2 x the power of negative half equals to 1 over 2 third x. Right? And after that, we need to find the value of f prime x naught. Right? Our f prime x is 1 over 2 third x. So means that f prime x naught, we just replace x here by x naught. And x naught from step 1 equals to 36. And when we solve, it is equals to 1 over 12. Okay? Alright, we just leave this answer as a fraction to make your final answer more accurate. Right? The final answer when we approximate here. Right? So that's why we leave this answer in fraction. Okay? And then step 4, we use this formula. Okay? Alright, from the given question, we have square root of 36.02. And then we write the right hand side formula, which is approximate to fx naught plus f prime x naught times delta x. Alright? Okay, actually, square root of 36.02 is actually fx naught plus delta x here. Okay, how we get this? Okay, how square root of 36.02 connect with fx naught plus delta x? Okay, alright. From step 2, we have fx equals to square root of x. And x can be right into the form of x naught plus delta x. So if we have fx naught plus delta x, means that we have square root of x naught plus delta x. And x naught from step 1 equals to 36. And then plus delta x from step 1 equals to 0.02. And when we simplify, we have square root of 36.02. So we get back from fx naught plus delta x here, we get back the given question, which is 36.02. Right? That's why we can write left hand side equals to the given question. And then we just use formula on the right hand side. Okay? Alright, from here, we substitute the value of fx naught. Okay, fx naught, okay, we get from step 2 here. Okay, and then we substitute the value of f prime x naught. Okay, f prime x naught, we get from step 3 here. Okay, and then we substitute the value of delta x. Okay, which is from step 1 here. Okay, So after we substitute, so we have 6, okay, for fs naught plus 1 over 12 for f prime x naught, and then times delta x, okay, which is 0.02. Okay, and then we solve, so we have 6.0017. Okay, correct to 4 decimal places. Alright. Hot tips when we solve linear approximation using differential. Let's say we want to find the value of square root of 36.02 using differential. First, you can check your answer using calculator. Okay, when we use calculator, square root of 36.02, the answer equals to 6.0017 up to 4 decimal places. So, if you get this answer using calculator, means this answer is correct, right? Coming up next, more examples for linear approximation using differentials. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.